Thank you for joining us. Welcome to Climate Central's monthly climate briefing. I'm Jen Brady, Senior Data Analyst and Research Manager here at Climate Central. If you're new to our work, Climate Central is a nonprofit, non-advocacy organization of scientists and communicators creating resources to help you understand and communicate about human-caused climate change. I'm going to be brief in my intros today because we have a very full agenda. Today's webinar will give an overview of 2026 weather and climate as we reach mid-year. Leading our discussion is Dr. Zach Labe. Zach is an expert in climate impacts, future scenarios, extreme events, and early warning predictions. In addition, he is a noted science communicator who also creates compelling data-driven visualizations. If you're on social media, follow Zach's got some great stuff out there. Zach was a scientist at NOAA's GFDL before he joined us here at Climate Central. Also joining us today, and Zach's going to introduce him more fully, is Hunter Jones of WMO WHO. So Zach, get us started with all the big news.
All right, thanks for the introduction, Jen, and thank you everyone for joining. We certainly have a lot to cover in the last month of global climate statistics and around the world and around the US, so we'll dive right in. And so today's sort of roadmap for what we'll be talking about is we'll be summarizing some of the big highlights globally and around the world for climate extremes, weather extremes. We'll be talking about recent heat waves, wildfires, current marine heat waves in the ocean. We'll, of course, provide an update on El Nino. So we'll have the latest forecast and the latest overall outlook for what El Nino is looking like now and heading into the near future. And then, as Jen mentioned, we'll have a special guest joining us to talk about global heat services. And so we'll get started right off with the climate moment of the month, which is talking about global temperature. So what you're looking at is a graph of global temperature by day for all months of the year. And why this is such a highlight is typically we talk about the global temperature anomaly. So oftentimes you hear climate scientists talk about the anomaly. What is the global temperature compared to normal? But I wanted to show the highlight here of what the actual global temperature looks like. And there's actually a seasonality to Earth's global temperature. And why I wanted to highlight it this month is because we're actually at the peak of the year. So typically during the summer months, right around late July and early August, we see the hottest average global temperature for Earth. Now that seasonality is normal and it corresponds with the Northern Hemisphere summer, more land in the northern hemisphere. So during the summertime, you get more push towards those higher temperatures than the southern hemisphere. So the global average is right around at its peak, and we're actually very close to the all-time warmest global temperature on record. So at this time of year, we're about 15 degrees Celsius would be normal, but of course we've had global warming. So you can see the average is that white dashed line. Where we are in 2026 is the yellow, and the red dot shows where we are most recently. And so now we're about 17 degrees Celsius, or that's about 62 degrees Fahrenheit is Earth's average temperature. So we're right around the peak. The all-time hottest value was recorded in 2024. It's a bit too early to determine whether we broke that record this year, but certainly next year you'll want to tune into this graphic. And so now we'll take a look what happened around the world last month in July. So July for all global and land and ocean areas, it was statistically tied for the warmest July on record. This was particularly warm for those areas that are in red. So those blocks that are in red indicate that that area had the warmest July on record for that location. So you can see big swaths of the eastern Pacific Ocean around El Nino were the warmest. We can also see over land areas, Western Europe being a real big highlight. Overall, global land area was the third warmest July on record, and global ocean area was by far easily the warmest July on record. So a theme you'll be hearing a lot through this presentation is just how really warm our oceans are right now. And so I did mention, global land was the third warmest, but if you actually take a look at land areas over the northern hemisphere, it was easily the warmest July on record for those areas. So this graph is showing the average temperature anomalies for northern hemisphere land areas from 1900 on the left all the way to 2026 on the right. So you can see overall that long-term increasing trend and easily where 2026 was the warmest July on record. Of course, we all live on land, so this means big impacts for where we are for communities all across the Northern Hemisphere in the last month. And we certainly heard about a lot of those heat wave headlines for many different parts of the area. And so if we actually take a look at now breaking it down into different continents, so if we take a look at the North America, it was also the warmest July on record for North America. It was the warmest July on record for Africa. Some of the largest temperature anomalies in July were across Central Africa, several degrees above normal with really high impact heat across those areas. In addition to those continents, it was also the warmest July on record for Asia. Again, these little graphs are showing the temperatures for those continents all the way back from 1900 through 2026. All of this really highlights how this is a global phenomenon where we're seeing all of these really high impact heat extremes leading to new records due to human caused climate change. And so I mentioned that the oceans are a big player in why we've been talking about all of this warmth. So what you're looking at is an animation of daily global sea surface temperatures for all years from the 1980s through recent. So I'm going to let this play one more time because I want you to watch how these lines change over time. So you can see that there's some oscillation in the 1980s, 1990s, we see it moving up. That's that long-term warming of our ocean. And then starting in 2023, really through now where we are in 2026, has been really a remarkable shift upward in the global average sea surface temperature. And so far for 2026, that red line, we've been setting daily records since early June. As we approach early September, it will be the 100th consecutive day of new global sea surface temperature records. So just really remarkable warmth in the last couple years, but especially in 2026 so far. And now taking a look at a map, where are some of those really warm areas of our oceans? So the darker red colors indicate where we have some of those highest temperature anomalies, those areas in particular with marine heat waves. So a couple areas stand out. We've had a really persistent marine heat wave across the North Central Pacific. You might also notice off the coast of South America, that band there, that's El Nino, which we're going to be talking a lot more about later in this presentation. You'll also notice there's really large, deep red colors near Europe, across the Mediterranean Sea and across Western Europe off the coast. That's another area that's had really persistent warmth, and we're going to zoom in just a minute into that area. But overall, you can see that there's a lot more red on this map than blue. Again, showing just how much warmth is around the world in our oceans. And while this map is showing just the top layer, that sea surface temperature, we also see new records being sent deeper in the ocean. So actually looking at some of the newest data that come in for the first quarter of 2026 set a new all-time high record for the amount of ocean deeper into going down to 2,000 meters deep in our ocean. And again, this is a really important indicator of global climate change because the ocean stores so much of that excess heat. So as I mentioned earlier, I wanted to zoom in on one of those really persistently warm areas across the Mediterranean Sea. And if you're interested, there's a new report out from the World Weather Attribution today that found human-caused climate change was the driver of some of this remarkable warmth we've been finding off the coastlines of Western Europe and into the Mediterranean Sea. In fact, there was a buoy reading in the Western Mediterranean Sea back from July that had sea surface temperatures rise to about 33 degrees Celsius or about 91 degrees Fahrenheit, setting a new all-time high sea surface temperature record for this basin. And we've seen many repercussions from this extreme heat. We've seen marine ecosystems be severely affected. We've seen new marine animals that are normally found in more farther south locations actually found in these higher latitude areas because there's just been so much warmth. So these marine heat waves really have impacts both in the ocean and for the coastal regions, which are also been more warm and humid in those, especially those warm overnight time temperatures. So what about in the US? The US has also had quite a remarkable month where this is a brand new record where July 2026 was the warmest month on record for the contiguous United States. So that means it was the warmest July, and because it's summertime, it also means it was the warmest all-time calendar month since records have been kept since 1895. And that was really coming from those nighttime temperatures that were exceptionally warm across the country, which I'll show a graph in just a minute. And looking at where those really warm areas were found across July, we can see record warm conditions were especially predominant across the western US, especially in Wyoming. But you can see that yellow orange shading across the whole country, showing pretty much everywhere was seeing above normal temperatures last month. And I want to put this in a little bit of perspective because this was quite a historic record for the US because the prior record was actually all the way back in July of 1936. And why that was so infamous, and because that was right in the heart of the Dust Bowl. And I wanted to just put a perspective on what did temperatures look like globally back in July 1936 compared to now. So what the map here is showing is it's showing the temperatures compared to normal globally. Again, red areas indicate that that was warmer than average. So if you look, you can see that there's this big red blob that's really over the central United States extending up through southern Canada. But you can see elsewhere there we don't really see anything that exceptional. So now let's compare what temperatures during that really extreme period during the Dust Bowl look like compared to 2026. So now we can see that that warmth is global. Those red colors indicating much more warmer than normal temperatures extend all over the world. We can see, that hot area over Western Europe, but many areas of elevated temperatures. And this really highlights the difference between 1936 during the Dust Bowl versus now, in that human-caused climate change is driving global warmth. So the Earth is much warmer on average than the Dust Bowl. And the Dust Bowl was much more of a regional extreme event. It was driven by both natural climate variability as well as land management practices that helped to contribute to some of that local warmth due to those drier grounds elevating those temperatures. So again, when you hear comparisons relative to the Dust Bowl, that was much more of a regional extreme event versus now where we're talking about the global warmth. Now, zooming back into the US, we know and we can calculate using Climate Central's Climate Shift Index, how did climate change boost those temperatures? So what this map is showing is it's showing the statewide average number of days where temperatures in those states were at least 2 times or more likely due to human-caused climate change. And so 36 states actually averaged at least 5 days with temperatures made at least twice as likely, again, due to climate change. We can see that was really elevated across the western United States and across states like Idaho and Colorado, Utah and Colorado, where again, there was more than 25 of days in July that saw temperatures, again, more than twice as likely due to human-caused climate change. We also saw multiple different heat waves that occurred during the month of July, and this was associated with those heat domes. It's probably a word you've been hearing a lot about in the news lately. And a heat dome is basically a type of weather pattern. It's associated with high pressure, and underneath that high pressure, you get a lot of dry, warm, sunny conditions. And they're often very persistent, so they're lasting for more than a couple days at a time. So during the month of July, we saw multiple of these heat dome weather patterns that contributed to extreme temperatures. One of them was found right around July 4th. It started off the month extremely warm across the eastern United States, where we saw many stations breaking all-time warmest days on record. So this is showing weather station data. Each of these numbers is referring to one of those weather station points, where anywhere you see a number 1, that means that the average temperature from July 3rd to July 4th of this year was the warmest on record for those stations. So we started off really, really warm. And again, one of the tools we can use here at Climate Central is from attribution, the idea of what can we attribute how climate change influenced those temperatures. So again, looking at that same period of July 3rd to 4th, we can see using these statistical algorithms that at least a 5 times or more likely due to human-caused climate change contribute to those extreme warmth. And we don't have time today to look at each of those heat domes that occurred during the month of July, but this is just an example of what we have been observing over the last couple of weeks. And so, as I mentioned earlier, one of the big drivers of that really historic warmth we saw in July was those nighttime temperatures. So, here's a graph of the average minimum temperatures for the month of July from 1900 on the left to 2026 on the right. So, you can see this year we are easily the warmest nighttime temperatures we had on record. And that's really important for talking about heat health impacts because those hot nights really limit our body's ability, especially for those who don't have access to sufficient cooling. It really contributes to our bodies not being able to recover from those hot summer days. And so we see more heat impacts during the night when we have those warm nighttime temperatures from higher heat stress and disrupted sleep and other related health risks. So it's really important to try to understand these changes in the warm nighttime temperatures that we're seeing. Turning to precipitation, so in addition to being warm, it was also pretty dry, as it's been for much of this year so far across the contiguous US. It was the 26th driest month on record. So we can see that there was particularly dry across the West, which that's not too abnormal in some areas, given it's their dry season. We can see a little bit of impact from the North American monsoon, which has brought some needed rainfall to parts of Arizona, parts of Utah, but not nearly enough to make up for the exceptional drought that they've been observing. So, taking a look at the latest drought monitor, we can see again that much of the US remains abnormally dry. In fact, more than 71% of the contiguous is abnormally dry or currently experiencing a drought. We can see where you see those deeper reds that indicating extreme drought or exceptional drought. They're continuing to occur across the West. Much of this is being driven by sort of that lack of snow we saw the winter. We had a historic snow drought across the Western US from this past winter. So all of the streams and outflow from the melt, the runoff was really early, and we just haven't seen any organized precipitation through spring and into summer across these areas. And it's certainly contributing, one of the contributing factors to some of the wildfires we have been seeing across those areas. If we take a look at another drought metric, which takes a look sort of at the longer term perspective for how unusually dry or wet conditions are, we can see again, July is at historic lows. And in fact, we are ranking and rivaling the Dust Bowl for having the second lowest average Palmer drought severity index on record. So this year continues the story for the US is very, very warm and very dry across many areas. And that continued through the last month. So, as I mentioned earlier, a lot of those drought conditions, those really extremely high temperatures, are contributing to more favorable environmental conditions for wildfires. So, here's taking a look at satellite imagery across the Western US in early August, taking a look at wildfires where you see the bright red spots, those hot spots being detected by satellite, and of course, all the smoke that's being transported from these really large, high impact wildfires. In fact, there's been some new records in recent days, one of them being that the Big Grass Fire is now the largest wildfire in modern Oregon history. And we're seeing many, many other records from these high impact wildfires. And they're extending not just in the US, but you can also see them extending into British Columbia. And all of that smoke is being transported further to the east, impacting areas. And so this is all part of a bigger trend, a bigger climate story where we're seeing more environmental conditions, more what we call fire weather days that are conditions that are favorable to allow some of these smaller blazes to grow into bigger ones or become more intense. And that trend is increasing due to the warming west, the drier west. And so we can quantify that. So taking a look in that region near that big grass fire in Oregon, we can see there's been an increase by nearly a month more of days that are favorable for wildfire development. On the left-hand side, you can see just a perspective of how big these fires are. What this is it's a satellite image that actually can basically take a look at light during the nighttime hours. So you can see major cities showing in that whiter shading, but you can see that the wildfires are so large in these areas that they're actually being detected on satellite like a big bright spot like we have from city lights. Again, really showing the remarkable amount of, it's not just one fire, but many fires across the Pacific Northwest stretching into Canada. And then here's just another perspective that I really think highlights what's been happening over the last month. So you're taking a look at an animation of wildfire smoke intensity across North America. going from the middle of July all the way to early August. So we had a remarkable amount of smoke across the US in the last month with really high impact air quality days with loads of pollution. It started from those wildfires across areas in Minnesota, extending into southern Canada that brought intense smoke and high air quality alerts to the northeastern US. And then those wildfires that grew across the western US later in the month and extending all the way into Arctic Canada. So it's really just showing the widespread extent of all the smoke. And this has impacts. Wildfire smoke is very harmful pollution. In particular, that fine particulate matter, sometimes called PM 2.5 for short, really accounts for a major threat to human health. And if we actually take a look at the data over the last 20 years, we can see that that smoke exposure is increasing across the US. And we'll soon have an update to this graph in just a few weeks here from Climate Central to take a look at some of the latest data as we continue to see more and more health impacts from this smoke pollution. And again, it's occurring not just for areas in the vicinity of wildfires, but even areas thousands of miles away are seeing these health impacts. So where are we so far this year, more broadly? As I mentioned earlier, we of course know it's been a very warm year. This is taking a look at those average temperature percentiles for the January to July period. Anywhere in red is having their warmest start to the year on record. So the same story continues. It's been a record warm year across most of the Western United States. In fact, 8 states so far have recorded their warmest average temperature during this period. And if you actually average the last 12 months as a whole, they're the warmest 12-month period on record for the contiguous United States. Globally, that's going to be a big story now as we're seeing global temperatures begin to rise in addition to climate change from that boost from El Nino. So far, we're ranking about the third warmest on year, though there's some differences depending on what data set you look at. But the question is, what will we end up later this year as we continue to see warmer and warmer global temperatures? So looking in the short term, what does it mean? We've been seeing all these extreme heat waves during the month of July. We expect, unfortunately, more heat impacts to occur. So looking over the next 1 to 2 weeks, we're expecting extreme heat to be really centered over the south central United States. This is also an area that's been highlighted by NOAA as at risk for rapid drought formation. So unfortunately, the likelihood for above normal temperatures is likely to continue across much of the country. The only area really that might escape some of the warmth in the short term is across the northeastern US. I also wanted to highlight, typically in these webinars, we focus on the past month, but I did want to give a shout out to a recent record, again, showing that this warmth continues into August, where on August 11th, the contiguous US, it set a new record actually for those warm nighttime temperatures, with 82% of the lower 48 experiencing the largest extent of minimum temperatures that saw a climate change influence. So you can see that reflected on the map with those bright red and yellow colors, again, just showing how warm nights have been this summer across the country. As far as precipitation and that drought that's been really persistent, we do expect to see some improvement in drought conditions according to the latest drought outlook across the West. Much of this is expected due to that enhancement of the North American monsoon that's bringing short-term drought relief, not really filling those reservoirs, but more trying to keep it a little steady across the West with those daily afternoon showers and thunderstorms. But unfortunately, more drought development is likely in that area experiencing the extreme heat, like from Texas extending up into Oklahoma and Kansas. All right, so now we'll move into El Nino, which I'm sure lots of people have questions about. And so we'll give a quick recap of what we've been seeing over the last month. So this animation is showing how ocean temperatures have evolved since July across that key region where we monitor El Nino. So again, El Nino is that band of warmer than normal sea surface temperatures across the central tropical Pacific Ocean. And El Nino is really important because it has both global climate impacts as well as regional climate impacts, causing some areas to have warmer or cooler temperatures or changes in precipitation. So we can see the takeaway here is that El Nino continues to rapidly develop. You can see that by that red area expanding over the last month. And if we take a look, if we average temperatures, ocean temperatures in one of those key monitoring areas, we can see just how remarkable that warmth is in that key monitoring area. So the yellow line is where we are in 2026. We are clearly seeing record warm ocean temperatures for El Nino. Now, note that some of this chart, some of it's coming from the added boost of El Nino, but some of it is also coming from long-term climate change, where climate change is contributing to a warming of ocean temperatures across this region. So it's a climate story as well as this natural climate variability story that's resulting in these record warm ocean temperatures. And so the latest ENSO discussion or El Nino discussion from NOAA really highlights where we're going for the rest of the year with really a remarkable statement. And I'll read it aloud where they said that during the October to December 2026 season, there is a 69% chance of a historic event that would exceed the strength of previous El Nino events dating back in our records to 1950. So again, we see more and more confidence with every month we give this briefing of just a historically strong El Nino event that's likely to occur. We can take a look at the latest like specifics. So what you're seeing here is the latest outlook from the NOAA Climate Prediction Center, which again focuses on one of the key indices where we monitor the strength of El Nino. It's called the Relative Oceanic Nino Index, or RONI. And so what you can see here, I've annotated sort of the intensities for you. The x-axis is showing seasons. So right around the peak outlook that's occurring in October, November, December into early next year, the current outlook suggests that we will exceed the very strong El Nino strength. And so I just want to also highlight that you've probably been hearing headlines in the news about a super El Nino or Godzilla El Nino, which are none of them being scientific terms, but they're equivalent essentially to very strong intensity. So again, what the takeaway here is we have more confidence in really this historic event for El Nino. And this has impacts for global climates. So typically we see an added boost on global temperatures during El Nino years. And so what we can take a look at is the latest forecast models for how warm are they predicting global temperatures to go for the rest of this year into 2027. So what we're seeing here by these predictions, so the average of those forecast models is that red line on the right-hand side. The yellow lines are showing individual models. And so we can see that global temperatures are very likely to set new monthly records basically for the rest of this year. If you actually calculate the global temperature so far in August, we're easily seeing the warmest start to August on record. And so it's only likely to become even warmer. And so currently we're seeing temperature outlook from these forecast models somewhere about 1.7 degrees above pre-industrial levels for individual months. That's very possible by January of 2027. And so, in addition to its impact on global climate, it also impacts regions and it has different effects. We do want to highlight that every El Nino is different. So, every El Nino has its own timing, its own intensity. There's also other patterns in the global climate system that also affect regional weather conditions. So while we can give you approximates for what typically conditions are like in your area during El Nino years, it really doesn't give the full picture just due to so much variability in the climate system. For example, we often see the strongest impacts during the boreal winter season, especially across areas like North America and like during the months of December through February. So often El Nino events are associated with wetter than normal conditions, for example, in Southern California, but that doesn't mean that it's likely to always occur due to that variability. In addition, I want to also point out that this El Nino is happening in a much warmer world than a past El Nino events. So I think we're still trying to understand what are the implications for El Nino happening in this warmer world. And I think we'll definitely see some surprises along the way later this year in terms of regional impacts. And so our takeaways are that we, again, with this month's briefing, we see even more evidence that this El Nino is likely to be one of the strongest in our historical records, if not the strongest. I also want to point out that human-caused climate change is still the primary driver of why we're seeing those record-breaking global temperatures. That long-term increasing trend is climate change, and El Nino is just providing that extra little boost. And again, lastly, every El Nino is different, and it certainly cannot explain every extreme event happening around the world. We'll be trying to understand El Nino's influences on different regions across the world, but again, each one is very different, and there's also other climate patterns in the global climate system that have different types of effects. And so, a question that we're getting nonstop is, will 2026 break the warmest year on record? And I think that still remains uncertain, that question. And so what you're looking at here is a graph of monthly global temperatures from 1950 to present. The individual bars are highlighted where red years are associated with El Nino and blue is La Nina years. And so we will wait and see how warm this year ranks. But I can say with a little more confidence, or maybe a lot more confidence, is that 2027 will probably most certainly break the new warmest year on record. So there will be plenty of climate stories to talk about in the coming months and coming year. And so here's my summary from this month. It was really a remarkable month. We saw July was tied for the warmest on record globally. It was also the warmest July on record for the contiguous United States, breaking that long-lasting record from the Dust Bowl. We see more confidence in a very strong El Nino event for later this year. Across the US, we see it's remaining very dry, very warm. And if you actually tally the number of extremes that we've been seeing around the US, using NOAA's US Climate Extremes Index, it's actually been the second highest on record for those areas in the last 117 years. And looking ahead, we see more warmth across the South Central US with a potential for flash drought in those areas. And so our next webinar is going to be in September 17th, and we're going to have a special feature looking back at this past summer. And we're going to be especially focusing on global areas and the different types of heat extremes we saw, as well as what was the climate change influence on some of those unprecedented heat waves like we saw across Asia, Europe, and North America. And so now I'm very excited to turn it over to our special guest today, Dr. Hunter Jones, who is the lead for Climate Service for Health at the WHO and WMO Climate and Health Joint Office. So I will turn it over to him and stop sharing my screen.
Okay, hopefully that's coming up for everybody. Thank you for the great setup, covering all of the weather and climate components that are really of interest this year, but especially the extreme heat that we've all been experiencing, enduring. What I want to talk about is what the World Meteorological Organization is doing to help Met services around the world. So think of organizations like the National Weather Service inside of NOAA in the US, help Met services develop heat services so that they can protect all of us from extreme heat by providing really essential information, warning, that sort of thing. So what I'll talk about really quickly is how we're framing, beginning to frame, I should say, the maturity of heat services at your Met services around the world, what the current state of those heat services is based on a couple of different survey tools that we have. WMO issues a member, it's not exactly a survey, but we expect our members to provide information on a regular basis. And so I have data from that I'll be sharing. So we'll have a lot of charts that we'll be looking at, as well as a more ad hoc survey that we did specifically on climate services for health among all of the Met services. And then I'll talk a little bit about the accelerator program, which is what my program is doing to enhance these heat services. First of all, what am I talking about when I talk about heat services? As I just mentioned, it's the essential weather and climate information that supports heat risk reduction. So beyond a heat warning system, which is an important component of a heat service, it's also the targeted information that might be used to support our health partners, critical infrastructure, commerce, and that sort of thing. So it's all of the heat information, advisory services, and whatnot that a Met service might provide along with its partners to support heat risk reduction. The challenge is that currently there's not a coherent definition of what we're expecting out of these heat services, norms, as well as operational institutional implementation expectations. And so we're trying to formalize heat services as a practice. To do this, we're using something called a maturity model. I don't have a fully baked example to show you of a maturity model. It's actually in development. And so what's on the screen right now is just an illustrative example of one attribute that we might track in a maturity model. But what a maturity model is essentially just a framework for evaluating on a number of different attributes how mature a service might be. So in this case, we're thinking about threshold calibration. Whatever country you're in, whatever Met service serves you, they probably issue heat warnings, watches, advisories, or some form of alerts, and they probably have a threshold that triggers them to send that alert out. So how did they set that threshold? Well, there are a number of ways you could do it. One is you could just be ad hoc and not set a threshold. A more advanced approach would be to have some sort of historical or maybe using a proxy threshold from a neighboring country. Going to a more mature approach, you might actually set that threshold from past experience, noting the impacts that you experienced in a previous heat wave or previous summer, working with your partners. And then the next level of maturity might be actually obtaining health data on mortality, morbidity, and developing an epidemiological model to inform where you might calibrate that threshold to be set. And Met services around the world are all working on this. They're all at different levels, and we're just trying to help them take those steps forward based on the data that's available to them. Some other attributes that we might consider, and I'll go into more detail on a few of these when I get into the survey component, are on the screen here. But just so you know, we're thinking about comprehensively how we can improve these services. Okay, the survey. I want to first start with information coming from our reporting from our members. It is less than half of the members that filled in the particular subsection on climate services for health. So just keep that in mind. This is not fully representing all of the members, the Met services of WMO. But when we asked them, 75 of the 75 respondents, the largest number that are the climate service for health, excuse me, that is the most commonly provided is for extreme heat. So that's why we're targeting heat services first as the kind of climate service for health that we are trying to mature and develop a framework around. But air quality, respiratory disease, vector-borne disease, there are a number of other climate services for health that we're interested in working on. Though the third most common response to this that maybe popped out to some of you is none. So in many cases, Met service members did not indicate that they were providing any climate services for health. So we'd like to improve that over time. In terms of the meteorological basis, so when setting that threshold, what kinds of variables are we talking about? Are we talking about minimum or maximum temperature? If so, all the Met services here lighting up in green told us that they at least use either a set threshold temperature like 35 Celsius maximum temperature for the day or something like that, or maybe over a couple of days, or they use a percentile basis. And so you can see this is a very popular way of setting those thresholds for issuing heat warnings around the world. I wish more of the world were filled in with responses, but we'll get there. The next one is using heat wave intensity as a metric. I'll explain this a little bit more in a moment, but this is really getting at the cumulative heat exposure over a number of days that adds up as the system heats up and doesn't have a chance to cool off. So when Zach was talking about those overnight temperatures, that's something that's captured by heat wave intensity metrics really well. And so to jump into it, what this looks like is as you experience your temperatures over a number of days, you can see that's what the squiggle is here. It's meant to represent the daily or hourly, in this case, maybe temperatures as they progress throughout a number of days. And what really makes heat dangerous in a number of places is that you can see the cumulative excess heat, this purple line that's kind of going up, goes up when minimum temperatures overnight are not cool enough to let all of that heat from the system discharge. So it could be in your body, it could be in your home, the building that you live in. And so over time, as the heat wave continues, the system can't reset. And so you have the cumulative heat that's really triggering a lot of heat impacts. So these are really good metrics for capturing that. We also have systems that use factors like, I'm sure many have heard of wet bulb globe temperature, UTCI, a number of these metrics that include humidity, include solar exposure, as well as in some cases, the clothing that you're wearing or how much you're exerting yourself. So fewer Met services use those. You can see Germany, for example, is one of the leaders in this area that's been using their representation of human experience of heat called Klima Mikel for over a decade. I've been aware of it, so it's been around for quite a while. Some other things that we might want to think about when developing heat services is how many of the Met services have trained their forecasters on impact-based forecasting. Impact-based forecasting is when you issue a warning, you don't just say how hot it's going to be, but you say what the impact might be, and you might also say how someone can protect themselves from experiencing that impact. Only a third of Met services responding to this survey currently do that and train their forecasters on this. So that is a clear area that we'd like to improve over time. In terms of validation and verification, again, a small fraction, 30%, have user feedback mechanisms according to the survey. And only 22% of respondents have access to cross-sector impact info and post-heat wave analytics. We would love to build that in to improve these services. When it comes to actually using a model, a heat-specific impact model in-house, only about, I don't even have a number on it, it's so small, a very small number of Met services in this plot do that modeling in-house, and a slightly larger number, 12.5%, work with another agency, probably a health ministry, to do that. So this is an area where to get those impact-based predictions and to inform the messaging, we would love to see more of those impact models put in place. To do that with your partners, you have to have agreements so you can work together. So fewer than half of Met services have a formal agreement or an MOU with their health ministry. And only about half in the survey that I've switched surveys now, just to note, I've switched to the other survey that I mentioned that we did just as the climate and health team, which had 41 respondents. So only half of the Met services that responded to us had an explicit mandate. When we think about working with our partners, we classify that as engagement maturity. And so these two figures, the left is extreme heat and the right is for vector-borne disease climate services for health. And as you go down this progression, this funnel, it's the extent to which they've engaged their partners to develop services and documented the benefits of those services. And so the take-home message is really, while heat is a little further along than other climate services, there's a lot of room left to improve the way that we develop those services with co-design, tailoring some of those predictions, informing policy. So this is something we'd like to develop. And I think this is my last slide from the various surveys. We asked our member Met services what kind of training gaps they had. First of all, training gaps are the number one thing that they identified they like to address. On the right, impact-based forecasting already covered, top priority. Epidemiology fundamentals, monitoring evaluation, and science communication are additional things that we'd like to work on with Met services around the world. So to summarize, I'm going to skip this slide because I want to move quickly to make sure we have time for questions. I want to kind of pivot into what we're doing at WMO to support member Met services as they develop their heat services. So we have this project called the Accelerator that's been funded by Rockefeller and by Wellcome, and that has been going on for about a year now and will continue at least through 2029, where we're trying to conduct a number of different engagements with Met services to support them. So we're developing a transdisciplinary professional fellowship program to hopefully put not only Met services, but also health ministry and health service partners through a process to learn together through a fellowship program. We're also developing training materials to support not only Met services and health ministries, but potentially a broader set of weather and climate and health interested participants who want to go through those trainings and learn how to do something like, set a heat wave threshold for a heat warning system. We're developing desks that will actually develop climate services for health in a number of locations. We've already launched one in Ahmad, which is a regional climate center that covers Africa. And we've launched one at IITM in India that's going to cover South Asia and develop climate services for health there. All of these desks will not only be focal points for improving heat services, but also things like dengue early warning systems, malaria early warning systems. So we're really looking forward to developing those. We're also building out our network of health focal points. We would like to see every Met service around the world have a health focal point that we can reach out to and work with. We already have a really good set of names and a good network there that we're going to be building on. And I'm coming to the end of my slides now. I wanted to provide some materials that you can look out for in the future. The one on the far left has actually already been released. It was developed by the WHO Euro region, and it is Heat Health Action Plan Guidance. So this came out in June, I believe, so it's very fresh. And I would encourage all of you to go look for that if you're interested in how something like a heat warning system might be part of a larger heat health action plan at a national or local scale. 3 more products that are coming out soon, hopefully by the end of the year. A global scientific synthesis report on extreme heat and health. So that's going to be a scientific assessment of not only the state of heat services, but just a lot of the heat mitigation activities, how we're actually supporting heat adaptation around the world. So that synthesis report will be a really important document that will kind of tell us where we're at as a global society in addressing extreme heat. Guidance on extreme heat and health early warning systems. So that will be very complementary to the heat action plan guidance that I talked about already on the left. And then a much more technical guidebook or handbook on extreme heat temperatures, indices, and statistics that's going to cover all of the different indices that you might ever want to know about. What is the wet bulb lobe temperature? What is the heat index? It's going to basically be an encyclopedia for all of those things. With that, I know that was quick, but I wanted to give you a quick survey of the kinds of things we're trying to improve for heat services, and I'd be happy to take any questions. Thanks for the opportunity.